Chapter 3. Who are you exactly? Leo hit deploy. The terminal returned 2 words. Access denied. He tried again. Same result. He had been working at Nimbus for 3 weeks, had been given access to the AWS account on his first day, and had been deploying to the staging environment without any trouble. But this was production. And production apparently was different. Maya looked over his shoulder at the error message. Who gave you that permission? Leo turned around. What permission? The permission to deploy to production. Who set that up? Leo opened the AWS console and started clicking through menus. Nobody had. There was no policy, no role, no explicit grant. There was also no explicit denial, just an absence. Nobody at Nimbus had ever sat down and thought about who could do what. That was the problem. The problem with passwords. Passwords are a bad model for computer systems, not because they're always weak, because they're binary. You either have the password or you don't. If you have it, you can do anything the account is allowed to do. That's fine for a single user on their personal laptop. It's catastrophic for a company's cloud infrastructure. Consider what Nimbus needs to manage: the web server, the database, file storage, networking, billing alerts, user accounts. If everything is protected by one password or even one set of credentials, then anyone who gets that password gets everything. And everything on AWS means the ability to delete databases, spin up servers that run up a $50,000 bill, exfiltrate every customer record, destroy backup data. Priya did not describe this in calm, abstract terms. She described it as a story about a startup that had a breach, got an $80,000 AWS bill in 24 hours from attackers mining cryptocurrency on their account, and shut down 3 months later. The room was quiet. So what's the alternative? Asked Tom. The concept: identity and access management. The alternative is a system where you don't give everyone the same key. You give each person and each service precisely the access they need. No more, no less. In AWS, this system is called IAM, Identity and Access Management. Think of IAM like the keycard system in a large office building. The building has dozens of floors. The server room is on floor 12. The finance office is on floor 8. The CEO suite is on floor 20. Every employee has a keycard, but each keycard only opens the doors that employee needs to open for their job. The intern can't swipe into the server room. The accountant can't access the executive floor after hours. IAM works the same way. You define who exists, identities, what they're allowed to do, permissions, and apply those permissions through policies. The building blocks of IAM. IAM has 4 core concepts. They build on each other. Users are individual identities. Maya has an IAM user. Tom has an IAM user. Each user has their own credentials and should only have the permissions they specifically need. Groups are collections of users. Instead of setting permissions for Maya, Tom, Priya, and Leo individually, you create a developers group with developer permissions and add them to it. When a 5th person joins, you add them to the group and they instantly inherit the right permissions. Roles are temporary identities that can be assumed by something: a person, a service, or another AWS account. We'll go deep on roles in Chapter 14. A user is a permanent employee. A role is a visitor badge. It grants specific access for a specific time or purpose. Policies are the actual permission rules. A policy is a document written in JSON internally, but you don't need to memorize the format, that says the holder of this policy is allowed to perform action X on resource Y, or denied action Z. The IAM evaluation model is, by default, everything is denied. Permissions must be explicitly granted. If a policy doesn't say you can do something, you can't. The principle of least privilege. This is the most important concept in all of security, not just IAM. Give people and systems only the access they need to do their job, nothing more. Priya called this the principle of least privilege. It sounds obvious. In practice, most teams violate it constantly, not maliciously, but out of convenience. Can we just give Leo admin access so he can deploy things faster? No. Can we just use the root account for everything? Absolutely not. The root account is the master key to your entire AWS account. It can do anything, including close the account itself. You should create it once, set up multi-factor authentication, and then never use it again for day-to-day work. Priya created separate IAM users for everyone that afternoon. She gave Leo permissions to deploy to the development environment. Not production, not billing, not networking, just deployment. "This feels restrictive," Leo said. "That's how you know it's right," Priya replied. What happens when you get this wrong? 3 scenarios in order of increasing severity. Scenario 1. An employee with admin access leaves the company. Nobody deactivates their account. 3 months later, they still have access. This happens constantly. IAM solves it. You disable the user. Instantly, everywhere. Scenario 2. A developer's laptop is compromised. The attacker finds AWS credentials stored in a config file with full admin permissions. Because the credentials have broad access, the attacker can do anything: mine cryptocurrency, steal data, delete backups. With least privilege, the credentials only work for their limited scope. Blast radius is contained. Scenario 3. A badly written application accidentally exposes AWS credentials in its logs. If those credentials have broad access, you have a catastrophic breach. If they have narrow access, only to the specific S3 bucket the application needs, the exposure is limited and contained. The pattern: access should be scoped to the minimum. Always. Not because you distrust your people, but because you can't control what happens to compromised credentials. Multi-factor authentication. The second lock. One more concept before we close the chapter. Even with least privilege, credentials can be stolen. Passwords can be guessed, phished, or leaked. IAM addresses this with multi-factor authentication. MFA requires something you know, password, plus something you have, a phone, a hardware key. Even if an attacker steals your password, they can't log in without also having your phone. MFA should be enabled for every IAM user. It is non-negotiable for the root account. Priya spent the afternoon setting it up for everyone. Tom asked if it was too much friction. Priya pulled up the breach story again. Tom set up MFA immediately. Strengths and limitations. IAM is the right tool for controlling who and what can access every AWS resource, implementing least privilege across users, services, and cross-account boundaries, generating an audit trail of every API call through CloudTrail integration, eliminating the need to share long-lived credentials between systems. Where IAM becomes difficult, IAM policies can grow into hundreds of statements across dozens of roles, and debugging an access-denied error requires understanding which of those policies is the effective one, a task that is harder than it sounds. The most common IAM mistake is not too little access. It's too much. Over-permissive policies created to just make it work become security liabilities that are painful to roll back after the fact. Write the minimum permission first. Expand only when something fails. Summary. IAM, Identity and Access Management, is how you control who can do what in AWS. The core building blocks are users, individuals, groups, collections of users, roles, temporary identities, and policies, permission rules. By default, everything in AWS is denied. Permissions must be explicitly granted. The principle of least privilege means giving each identity only the access it needs, no more. The root account can do anything, including catastrophic things. Lock it behind MFA and use it as little as possible. Enable MFA for every IAM user. Non-negotiable. Exam tips: SAA CO3, Domain 1, Task 1.1, Secure access to AWS resources. Everything is denied by default. An explicit allow is required. If a policy doesn't mention an action, the action is denied. Explicit deny always wins. If any policy in the chain denies an action, that deny cannot be overridden by an allow anywhere else in the chain. This catches many candidates off guard. Root account equals IAM admin. The root account is a separate credential from IAM. You cannot delete the root account. You can and should restrict when it's used. IAM is global, not regional. IAM users, groups, roles, and policies exist across the entire AWS account, not per region. Roles are the preferred way to grant access to AWS services. If an EC2 instance needs to access S3, you attach an IAM role to the instance. You don't store credentials on the machine. This pattern shows up constantly on the exam. Exercises. Exercise 1. Recall. In your own words, what is the difference between an IAM user, a group, and a role? When would you use each one? Hint. Think about the keycard building analogy. Which one is a permanent card, which is a department grouping, and which is a visitor badge? Exercise 2. Exam practice scenario. A company runs a web application on EC2 instances that need to read files from an S3 bucket. A junior developer suggests storing AWS access keys directly in the application code on the EC2 instances. The security team objects. What is the most secure and operationally appropriate solution? A. Store the access keys and environment variables on the EC2 instance instead of the code. B. Create a dedicated IAM user with S3 read permissions and share the credentials with the development team. C. Attach an IAM role with the appropriate S3 read permissions directly to the EC2 instances. D. Use the root account credentials to give the application full access to all AWS resources. Hint 1. The problem with storing credentials anywhere on the instance is that credentials can be leaked. Is there a way to give the EC2 instance access without using credentials at all? Hint 2. AWS has a mechanism where services can be granted permissions without needing static credentials. What is that mechanism called? Hint 3. IAM roles can be attached to EC2 instances. When they are, the instance automatically receives temporary credentials that are rotated by AWS. No static credentials needed. Answer. See explanation. Attaching an IAM role to an EC2 instance is the correct pattern. The instance automatically gets temporary rotating credentials through the EC2 metadata service. There are no long-lived credentials to leak, rotate, or accidentally commit to a repository. Why not A? Environment variables on an EC2 instance can still be leaked through application logs, debugging endpoints, or if the instance is compromised. Static credentials are the problem, not their location. Why not B? Creating a shared IAM user and distributing credentials to a team violates least privilege and makes credential rotation a nightmare. If one person leaves, you can't easily revoke just their access without changing shared credentials. Why not D? Using root account credentials for any application is a severe security violation. The root account has unlimited access, and its credentials should never leave the account owner's control. SAA CO3 Domain 1, Task 1.1, IAM Roles, Least Privilege. Exercise 3, Architecture Challenge, Optional. Nimbus is onboarding 3 new developers next month. Each will need different levels of access. One works on the database layer, one on the application servers, one on the front-end static files. There's also a CI/CD pipeline that needs to deploy code. Design an IAM structure for this scenario. What users, groups, roles, and policies would you create? What would be the most important least privilege boundary to enforce? There is no single correct answer. Think about minimizing blast radius if any one identity is compromised. Post-credit scene. By the end of the day, every IAM user had MFA enabled. Leo's account had been reduced to developer-level access. Deploy to the dev environment, read from the shared config bucket, nothing else. He had tried once to access the production database. Access denied. Is this what it feels like to be trusted but not too much? He asked. That's exactly what it feels like, Priya said. The next morning, Tom arrived early and found something that made him immediately call the team in. On the AWS console, he could see that their website was getting traffic, more than they'd expected, and the web server, Leo's original one, was running hot, really hot. We have 100 concurrent users, Tom said, and 1 server. In the next chapter, the first server, renting a computer in someone else's data center.